just around the corner. Keeping this in mind, we know each and every one of you is really excited, but is also looking for the last final push and the fillip that is going to add those extra 5, 10, 15 percentile to your final CAT score. Well, because of this, BYJU'S Exam Prep brings to you the last lap to CAT 2022, starting on the 17th of October all the way till the 20th of November. Yes, 4.5 intensive, in fact almost 5 intensive weeks of preparation. What more, the focus is predominantly going to be CAT, which means, as we know, time, speed, distance and time and work in totality have almost equal weightage or sometimes even more weightage than geometry. So can we go ahead and leave geometry and just focus on these two? Can we go ahead and leave entire theta para jumbles and still score a 99.99 percentile in verbal? Yes, we can. This and much more in terms of preparation, in terms of intensive questions that we're going to look at and the smartest way of going ahead and solving that. So catch us on the BYJU'S Exam Prep app, and in case you missed that, on YouTube. But go ahead, download the BYJU'S Exam Prep app and also get a 99 percentile kit which is going to help you ace CAT 2022. See you soon.
Hi friends, with just 20 days left to CAT, I'm sure that all of you must be doing the revision in a proper way, and you are utilizing whatever time that you have for yourself to go ahead and revise each and everything for this examination. Now, in this journey that is taking us towards CAT 2022, I, Gourav Gupta, welcome you once again on the YouTube channel of BYJU'S Exam Prep with yet another session in the series Last Lap to CAT 2022. Now, today in this session, we are going to take on modern maths. We'll say that it is not like the most important topic that comes in QA. I agree that this is not the very important topic that comes in QA, but definitely those students who are targeting some wonderful scores in QA section, let's say if you're targeting above 90 percentile or above 90 percentile in this particular section of CAT, then you cannot afford to miss any of the topics. And modern maths is one such topic in which from which we can easily find 2 or 3 questions out of whatever number of questions that we are going to see in CAT. So yes, I can say that the weightage is not as high as arithmetic or algebra, where the arithmetic of algebra is somewhere around 30 to 35%. But yes, we can say that out of the total number of questions that you are going to see in the QA section, we may have 10% of the questions, 10 to 15% of the questions coming from modern maths. So good evening all of you once again, and welcome back to yet another session of Last Lap to CAT 2022. I'm hoping that all of you are preparing well, all of you are attending all our live sessions, and once you are done with these live sessions, then you are devoting enough amount of time in practicing some questions. You are taking mock papers, you have joined any of the mock test series, and you are taking these mocks regularly, and as well as analyzing these mocks properly so that you can learn from your mistakes. So friends, let us begin with this session of modern maths. Now, first of all, we'll talk about the relevance of this particular area. Varun is asking, sir, in mock CATs, I'm scoring 80 overall. So can I be able to reach 90 till the time of actual examination? Now, Varun, what my experience says that if any student is getting 80 percentile regularly in mock papers, then understand that the mock test series, generally the students who are serious in their studies, these are the students that will be taking mock test series. All right. So out of the serious candidates, if you are above 80% of the candidates, then I can say that on the day of CAT, a lot of students, including non-serious candidates, will be taking this examination. The students who are not preparing the way you are preparing, they will also be taking the examination. So it will be very easy for you to get 90 percentile or above in actual CAT examination. All right. Okay, so Shweta, I have answered this question. I believe a lot of you must be thinking about this particular thing. So guys, understand this is basic calculations. Okay, so you are the student who is basically preparing for all these examinations. You are giving your 100% on each and every day up till 27th of November. All right. Now, out of 2 lakh, approximately 2 lakh candidates who appear for this examination, I'll say that the number of serious candidates whom you have to do the competition. So this number will be somewhere around 25 to 30,000 only. So out of these students, if you are able to score 80 percentile, all right, then I can say that you have a chance of scoring above 90 percentile in the actual examination. Okay. Okay, right. So let's begin with this session, all of you. Now, first of all, if I talk about the weightage of this particular area in CAT, then I have already defined that the weightage is somewhere around 2 to 3 questions you can expect in CAT. Now, we have seen instances where the number of questions is also more than 3. All right, but I'll stick to the pattern of last 5 years. I'll stick to uh, I'll say the pattern of last 5 years, and we'll see if like how many questions have appeared in these last 5 years. Now, first of all, the topics that I will put under modern maths will be set theory and Venn diagrams. You all know that this is a very important area, not only from quant's point of view, but also from LRDI point of view. Okay, so if you are not seeing any questions of set theory or Venn diagrams in QA section, then there is a probability that you may see the questions from Venn diagrams or set theory in LRDI section. So this is one of the very important areas in modern mathematics. Next is permutation, combination, and probability. So yes, definitely, as I have mentioned, that you will not find a lot of questions from this particular area. Okay, but over the last few years, we have seen at least one question coming from PNC or probability. All right. The next area is statistics, and I have not seen any question on statistics in the last 4 5 years. Okay, so not very important. The concept of mean, median, mode, standard deviation, variation, regression, and so on and so forth. So probably you may skip this area, but make sure that you understand the basic concepts of mean, median, and mode. All right. Okay. Now looking at the trend over the last 5 years. So this is the trend. So if I'll talk about the last year, in all the 3 slots. So we have seen one question from these areas in slot 1, one question in the slot 2, and there were 2 questions, one from Venn diagram and one from PNC in slot 3. All right. The similar was the story in CAT 2020. No question in slot 1, one question each in slot 2 and 3. Now in CAT 2019, again, there were less number of questions from this area, but if you'll go before 2019, you will see that in these 2 years, CAT 2018 and CAT 2017, we have seen 3 questions. We have seen 3 questions in every slot coming from modern mathematics. All right. Again, we can see that the weightage of PNC and probability was not high, but you can see that in CAT 2020, CAT 2017, this is not 3, this is 4. So 2017, there were 4 questions from PNC and probability. Okay, so yes, we have an equal chance of these questions reappearing in CAT 2022, having a good weightage in our examinations. Okay, so definitely we cannot afford to leave this area if we are looking forward for a 90 or 95 above percentile. Okay, so this was the trend over the last 5 years. All right, now let's start this session with some of the most important formulas from these areas. So let's do a little bit of warm up, okay, so that you all will be able to solve the questions in a proper way. So first of all, talking about set theory, especially a two-set Venn diagram. Okay, so let's talk about a two-set Venn diagrams, Venn diagrams which involve 2 parameters A and B. So this is the Venn diagram. This is how we draw the Venn diagram. So where parameter A, the area, the circle, the region represented by parameter A and parameter B are partially overlapping each other. All right. Now, if we draw this diagram, then we can see that the entire region that we call as the universal set. Okay. So the entire region is divided in 4 portions. I'll name these, or I'll number these regions: region number 1, region number 2, region number 3, and region number 4. All right. Now, if I talk about region number 1, so region number 1, that is this shaded region, represents all those parameters, all those numbers which comes only in A. So region number 1 will be for only A. All right, fine. Now similarly, region number 2, can you all tell me what will region number 2 represent? So region number 2 will represent only B. Region number 3 represents both A and B. All right, and region number 4 will represent none of these. All right, none of the regions A or B. Right. Now we have to be very careful when we are dealing with this particular word only. All right. So in the question, the information that is given to you, if this is for the parameter A or for the parameter only A, this is one thing that we need to understand. All right. So if the question says that, the value of parameter A is equal to 40, then that means this entire circle is equal to 40. All right. Now, if they say that only A is equal to 35, so we can say that the region that I'm shading, this region will be equal to 35. All right. That means the portion that is now I am shading. So this region. So if A is 40 and only A is 35, then what will be the value of this region, which is both A and B? So what will be the value of both A and B? So total A, that means the complete circle is 40, and this portion which is only A is 35. So we can say that both A and B will be equal to 40 minus 35, that is equal to 5. All right. So you have to be very careful if the information is given about A or only A, right? Okay, now moving ahead. So this is the Venn diagram, that is what we draw. Now there is a formula that is related to a two-set Venn diagram that says that A union B is equal to A plus B minus A intersection B. So when I'm calling A, so when I'm saying A, that means I'm considering this entire region A. All right. So let me again number these regions: region number 1, region number 2, region number 3, and region number 4. Now we are calculating the value of A union B. That means all those values, all that region which is lying under A or B. All right. So on the left hand side, region number 1 should be there, region number 2 should be there, and region number 3 should be there. So that means I need this particular thing, which is A union B. Right. Now the formula for A union B is A plus B minus A intersection B. Now what is this A? A is both the regions 1 and 3. All right. Similarly, B covers region number 2 as well as region number 3. Now when I'm looking for A union B, then you can see that region number 3 is counted twice. So that means it should be removed once, because there should not be any duplications. So that is why I have subtracted A intersection B. A intersection B means the region that is under both A and B. All right. So this is region number 3. So I have subtracted region number 3 once. All right. So I'll be left with region number 1, region number 2, and region number 3. Okay. So there is no need to cram these formulas. You can always understand these formulas. ये वाले फॉर्मूले रटने की जरूरत नहीं है. If you have a clarity about what you require, okay, and clarity about each and every region, the nomenclature of each and every region, then you can devise your own formula. All right. Okay. Now, Harsh is saying, because in the official mock released by CAT last year, one could only see the questions. Harsh, I don't understand your question, because in the official mock released by CAT last year, one could only see the questions. So Varun, can you please clarify what your query is? Please do that, Harsh. Okay. All right. Now let's move on to the next portion. Venn diagram involving three parameters. So you have three parameters A, B, and C, and all of them are overlapping partially. All right. Now let us get a clarity about all these regions. Now exactly one. वाला region कौन सा होगा? So exactly one will be this region, and this region. So that is A plus B plus C. Okay. Now all of you tell me which regions will represent exactly two parameters of the three. Which regions will represent exactly two out of the three parameters? Come on. Exactly two is what I want. So all those regions which are covered in exactly two parameters, these are D, E, and F. All right. So D, E, and F are for exactly two. Right? So exactly two is D, E, and F. Absolutely correct. Kunal and Akhil. Absolutely correct. Okay. So a lot of you have given the answer. Nice. Now tell me exactly three. कौन सा वाला region exactly three को represent करेगा? Exactly three is represented by which region? I'm showing it. So exactly three is represented by G. All right. Am I clear to each and every one of you? Okay. Now, which region represents none of them? So none of them is H. So it is H, none or neither of these parameters. All right. So it will be equal to H. All right. Now tell me which region or regions will represent at least two parameters. At least two parameters, which region or regions? Quickly tell me. Let's see how many of you can give me a correct answer for this. At least two. I'm looking for at least two. So at least two is represented by, so at least two, that means minimum two. Okay. So two or more than two. So two parameters or three parameters. So this will include D, E, F as well as G. All right. So it will be D, E, F and G. Am I clear? Now at least one will be all of them A, B, C, D, E, F and G. Okay, and that is called at least one. That is called the union of A, B and C. The union of A, B and C, and the formula for this is given by, as you can see at the top of this slide. So A union B union C will be equal to A plus B plus C. Now let us understand this formula. Okay? The way I have explained you the formula for two parameters, let me explain the formula for three parameters, and then if you will get confused, if you'll forget this formula at the time of the examination, then you can derive this formula by yourself. Okay? Now A union B union C, that means it should be A, B, C, D, E, F and G. All these parameters taken once. Now on the right hand side, if I'm writing A, now A means all the regions that comes in A. Okay, so capital A, which regions will come under this? A, D, E and G. Then I'm writing B. So under B, I have small b, D, F and G. And then finally C will have, look at the circle of C. So this is the circle of C. So it will be C, E, F and G. All right. So up till this A plus B plus C, I have considered all these regions. Now there should not be any duplications, but observing these regions that I have considered, you can see that region number D, region D is taken twice, E is taken twice, F is taken twice, and G is taken 3 times. All right. So what I'll do is I'll subtract A intersection B. Okay. Now let us understand the meaning of A intersection B. Now from this figure, A intersection B will be the region that is covered in both A and B, irrespective of C. Okay. So you can see that this particular region is covered in both A and B. All right. So if I'm subtracting A intersection B, that means I'm subtracting D and G. Similarly, if I'm subtracting A intersection C, so A intersection C, A और C में कौन से दो regions common है? This portion that I have just highlighted, E and G. All right. Similarly, B intersection C, it will be F and G. All right. So this particular thing is subtracted. Now I have subtracted D once. So D को एक बार हटा दिया मैंने, ऊपर से cancel कर दिया. E को एक बार हटा देते हैं. E is removed once. F is also removed once. All right. Fine. So D, E and F, when they were taken twice, I have removed them once. But G is removed 3 times. I considered G thrice and it is removed 3 times. Okay. So now I have got rid of all of G's. So that means I'll have to add G once. So G को एक बार add करना है. So this portion at the end of this formula, A intersection B intersection C, has been added and I'll get the formula. Okay. So this is how you can remember the formula. This is how you can understand this particular formula. All right, fine. So that was some formulas related to the set theory, 2-setter and 3-setter Venn diagram. Okay, now let's move ahead and look at some of the basic things for permutation combination. Okay, let's move ahead. Now for permutation combination, some of the basic things that all of you would already know, I'll quickly move so that we can start with the questions. So quickly look at the questions, the formulas of permutation combination. So some standard results. NCR is equal to NCN minus R. Okay, NCR is equal to NCN minus R. This is the first formula. Now the second formula is the value of NC0. The value of NC0 is always equal to 1. Now NC0 means number of ways of selecting 0 out of n. All right, so it will be equal to 1. Similarly, NCN will also be equal to 1. That you will see in some time. Okay, so NC0 is equal to 1. NCN will also be equal to 1. Moving ahead, NC1 will be equal to n. That means number of ways of selecting 1 out of n will be equal to n only. And like I said, NCN is also equal to 1. That I have already written up there. Okay. Right. Now, apart from this, try to memorize the value of the factorials, n factorial up till 7 or 8 factorial. Okay? Like 6 factorial, I believe सबको value याद होगा. Can you quickly write the value of 6 factorial? All of you, come on. 6 factorial का value. The value of 6 factorial is 720. 7 factorial, 8 factorial. I want all of you to remember the values up till at least 7 or 8 factorial. This will help you in the examinations, like doing the calculations faster. Okay. Now, Harsh, you're asking, what I was asking was that we have an option to see the whole question paper at once in the real CAT exam, right? So are the questions visible along with their options too? Yes, Harsh, you are right. So we have an option of looking at the entire question paper during the examination, and yes, each and everything will be visible. Okay, with the questions which have options, definitely the options will be visible in that. Okay. All right, आगे चलते हैं. Oh, people have also written the value of 7 factorial, which is 5040. Multiply by 8 भी कर दो. So 5000 into 8 is 40,000. 40 into 8 is 320. So 40,320 will be the value of 8 factorial. Okay, 40,320. All right. Okay, so up till 8 factorial, you can remember these values. Right. Now let's move ahead and look at the next few formulas. Now combination with number of paths. Okay. Now total number of ways of selection of n different things. Now leave this for the time being and look at this number of ways of selection of n from n different things. So let's say there are n distinct different balls. Okay, so there are n different balls. Now out of these n different balls, if I want to select 0 balls, then the number of ways will be NC0. If I want to select one ball, number of ways will be NC1. For two balls, it is NC2 and so on. If I want to select n number of balls, the number of ways will be NCN. So here I'm writing the formula for total number of ways of selecting from n different balls. Or you can say that number of ways of selecting 0 or more balls, number of ways of selecting 0 or more balls out of n distinct balls. So number of ways will be NC0 plus NC1 plus NC2 up till NCN, and the value of this entire expression is equal to 2 raised to the power n. Alright, so number of ways of selecting 0 or more balls out of n distinct balls is equal to 2 raised to the power n. In case you want to select at least one ball, then the number of ways will be 2 raised to the power n minus 1. So number of ways will be 2 raised to the power n minus 1 if you want to select at least one ball. Alright, so please note down all these formulas. Must remember all these formulas. Next is if all the balls are identical. So number of balls are identical, then the number of ways of selecting 0 balls will be 0. 1 ball, one way. 2 ball, again one way. 3 balls, one way. 4 balls, one way. And n balls, there will be one way. So the expression was not written correctly. So 1 plus 1 plus 1. So 0 balls के लिए भी one way होगा, 1 ball one way, 2 balls one way, 3 balls one way, and so on. So total number of ways will be equal to n plus 1. Alright, so n plus 1 will be equal to the total number of ways. Again, if you want to select at least one ball, out of n identical balls, then the number of ways will be, this was the total number of ways, इसमें से 1 minus कर दो. So always remember the formula like this, n plus 1 minus 1. Alright, fine. So for n distinct balls, the total number of ways is 2 raised to the power n. For n identical balls, the number of ways is n plus 1. At least one चाहिए तो minus 1 कर दो दोनों formula में से and you will get the formula. Alright, okay. Now moving ahead and looking at the next formula. Next is circular arrangements. So can you tell me, any one of you, what is the number of circular arrangements of n distinct items? Or let's say there are n persons. In how many ways n persons can sit around a circular table which has n number of chairs? Yes, anyone with a formula? No, Varun, you cannot do that. Alright, Pragya, good. Akhil, good. So yes, for circular arrangements, if there are n articles, then the number of ways is n minus 1 factorial. Okay. Now, n minus 1 factorial, this particular formula will be used if there is a difference between the clockwise and anti-clockwise arrangement. Alright. So if n number of people are sitting around a circular table, then definitely the clockwise arrangement will be different from anti-clockwise arrangement. Alright, so there are some cases in which the clockwise and anti-clockwise arrangements are not different. Okay, they are considered as same. The examples are if you are making a necklace with the circular beads. Okay, so with the beads, if I'm making necklace or there's a garland of flowers, so in such cases, clockwise and anti-clockwise arrangements are considered as same. So for those type of questions, the formula for the number of circular arrangements will be equal to n minus 1 factorial divided by 2. Alright, so always remember, for the cases in which anti-clockwise and clockwise arrangements are same, that means there is no difference between clockwise and anti-clockwise, then the number of ways will be, or the number of arrangements will be n minus 1 factorial whole divided by 2. Absolutely, Pradeep. So garland of flowers, necklace, such type of questions, you will divide the value by 2. Okay. All right. Now let's move ahead and look at the next formula, the formula for the dearrangements. Okay. Now dearrangements means when none of the objects will sit at or will be assigned its given place. So the famous example is of letters and envelopes. So let's say there is a person who has written letters to his 5 different friends. Okay, so there are 5 letters that he has written to 5 different friends, and there are 5 envelopes on which he has written the addresses of these respective persons. Okay, so dearrangement means the number of ways in which no letter will be inserted in its correct envelope. No letter will be inserted in its correct envelope. So this is the formula for dearrangement. So you can remember this formula. This is the general way of this formula. N factorial bracket 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial and so on up till 1 upon n factorial. The important thing to be noted down in this formula is the alternate plus minus signs. Okay. So alternate plus minus sign are very important in this particular formula, right? So make sure that you remember this formula, and this formula is used directly as well. So direct questions bhi aate hain is formula pe. So it will be better if you remember this formula. Okay. Now the table below shows you the number of dearrangements for any number of items. So for one item, leave this. So when n is equal to 1, wait. So n is equal to 1, it will be 0. Wait. So n equal to 1, the number of dearrangements will be 0. N equal to 2, it will be 3. Alright. So sorry, n equal to 3, the number of dearrangements will be 2. N equal to 4, the number of dearrangements will be 9. N equal to 5, the number of dearrangements will be 44. I have learnt it up till 265. So when the number of envelopes and letters is equal to 6, it will be equal to 265. So you also may remember up till the value of 6. Okay? So when n is 1, it will be 0. When n is 2, it will be 1. So starting from n equal to 1, you can remember up till n equal to 6. These numbers. Okay? Varun, the alternate signs. So if you will look at the derivation of this formula, then you will be able to understand why we have applied the plus minus sign. This is not for incorrect or correct. No, this is not. So this plus minus alternating sign is basically what we are doing is we are subtracting total from n factorial, okay, and then adding some extra cases that we have subtracted and then subtracting them again and so on. So this is a very lengthy formula. There is no need to do the derivation of this formula. I'll suggest you to just remember this formula, and this formula will be applied directly in the questions. Okay. आगे चलते हैं. Next is a very important rule, the distribution rule. Okay. So distribution rule is basically if there are n identical items to be distributed in R distinct groups. Okay, fine. Yes, Prabhat, n is the number of letters or the envelopes. Okay, fine. Now, music core, no need to understand the formula. You just need to cram this formula. इस formula को याद कर लो. Remember this formula, note down. You will find this formula in a lot of booklets, and you can stay on this screen and note down this formula, and later on you can remember this formula and can be applied directly. So let's say चलो मैं explain करता हूँ. Let's say the value of n is equal to 5. So I'll look at this formula for n equal to 5. So the formula will be 5 factorial bracket 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial. Okay. Now the first two terms will get cancelled, 1 minus 1 upon 1 factorial. So this part will be 0. So I'll start from 5 factorial divided by 2 factorial. Now 5 factorial divided by 2 factorial will be equal to 60 minus 5 factorial divided by 3 factorial. It will be equal to 20 plus 5 factorial divided by 4 factorial, this is 5, minus 5 factorial upon 5 factorial, it will be equal to 1. So if you'll simplify this, calculate or resolve this expression. So 60 minus 20 is 40. 40 plus 5, 45 minus 1, 44. So the value when n is equal to 5 is equal to 44. All right. So this is how you can apply this formula for any value of n. Directly applicable है formula. So कुछ इसके लिए concept में जाने की जरूरत नहीं है, derivation में जाने की जरूरत नहीं है. You just cram this formula. Okay. Right. आगे चलते हैं. So the important thing, distribution rule. So if there are n identical items and to be distributed in r distinct groups, I'll directly ask you this question. So let's say you have an equation like a plus b plus c plus d and so on is equal to s or is equal to whatever. So number of variables is r and this sum is s. So what will be the number of number of whole number solutions? Number of whole number solutions का formula क्या होता है for an equation like this that you have seen and or that you can see at the top of the screen. So number of variables is r and s is the sum. So the number of whole number solutions for this type of equation is s plus r minus 1 c r minus 1. Okay. Now in this case n is the total number of identical items. So the formula will be n plus r minus 1 c r minus 1. Now this is the total number of whole number solutions. All right. Am I clear? I hope most of you would remember this formula, n plus r minus 1 c r minus 1. All right. Akhil, absolutely correct. Good. Jaydev, nice. So this is the formula that you must remember. Now this is the formula for number of whole number solutions. Now similarly, we have the formula for number of natural number solutions. So I'll write the formula. The formula is s, or in this case I have n, so I will use small n instead of the sum s. So n minus 1 cr minus 1 is the formula for number of natural number solutions. All right, clear? Okay, now let's move ahead and look at the next formula. Now in the first case, we have distributed n identical items in r distinct groups. Now if you want to distribute n distinct objects, n distinct items in r distinct groups, like in how many ways 7 letters can be posted in 3 letter boxes. So we have 7 letters, all these letters are distinct and the letter boxes are also distinct. All right. So in how many ways 7 distinct letters can be posted in 3 letter boxes? So the number of ways will be how much? Now if I take one letter, it has 3 ways to be posted. Second letter also has 3 ways. Third letter also has 3 ways, and so on. Seventh letter also have 3 ways. So the answer should be 3 raised to the power 7. All right. 3 raised to the power 7 is the final answer. Similarly, the formula for this will be equal to r raised to the power n. So Pradeep, you are absolutely correct. Akhil, Varun, 7C3 will not be the answer because any number of letters can be posted in any letter box. Okay. So the correct answer here will be r raised to the power n or 3 raised to the power 7. Right? Am I clear? So 7 into 6 into 5 will not be the answer. It will be 3 into 3 into 3 and so on 7 times. So 3 raised to the power 7 will be the final answer. Okay. All right. Now that is all about the formulas. Now let us practice some questions. Now we'll practice these questions in the similar way. So we'll be taking these questions one by one. I'll be displaying the questions one by one for 1 minute. We'll give you 1 minute to solve that question, after which we'll do the proper analysis of that. Okay. Chaliye. So first question on your screen now. In a party, out of every 9 guests eating noodles, 2 eat pizza as well. For every guest eating at least one of these two dishes, there are two guests who eat neither. If 21% of the guests eat only noodles, then what percentage of guests eat only pizza? A very simple question to start with from two set Venn diagram, set theory. All right, music course says option C, 8.33. Varun also says 8.33. So let's begin and quickly draw a Venn diagram. So I draw a universal set, a set of students who will eat noodles and pizza partially overlapping each other. Okay. All right. So this is for noodles and this is for pizza. Now the first line says that out of every 9 guests eating noodles, so if number of guests eating noodles is 9, then 2 will eat pizza as well. So for every 9, 2 will eat pizza as well. So if 9x is the number of guests who eat noodles, then out of these 9x, 2x will eat pizza as well. That means 2x will eat both noodles and pizza. Okay, so for every 9 eating noodles, so if number of noodles eaters is 9, then number of eaters who will eat pizza as well will be equal to 2. Okay, so pizza as well. This is very important, right? So if number of noodles is 9x, then both will become 2x, right? Next statement, for every guest eating at least one, there are two guests who eat neither. So at least one and none. इनका ratio दिया हुआ है. So if this is 1, this is equal to 2. So if at least 1, that means the region covered by these two circles is 1, then none will be equal to 2. Okay, so they are in the ratio 1 is to 2. So what I'll do is now I'll start by assuming the total number of guests as 300. So if total number of guests is 300, then the guest who will eat none of these two items will be 200, and the guest who will eat at least one of these items will be equal to 100. All right. Am I clear up till this point? So two statements are done. Next statement, if 21% of the guests eat only noodle. Now in this Venn diagram, number of guests who will eat only noodles will be 9x minus 2x, that is 7x. So 7x is represented by 21% of total number of guests, that is 300. So the value of x will come out to be 63 divided by 7, that is 9. So the value of x will be equal to 9. Okay, then we have to find out percentage of guests eat only pizza. So only pizza calculate karna hai, right? Now total number of noodle eaters 9x, 9 into 9, it will be 81 out of 100. So only pizza will be equal to 100 minus 81, that is equal to 19. So number of guests who will eat only pizza will be equal to 19, and it is what percentage of total guests? 19 upon 300 multiplied by 100, and that should be equal to 6.33%. So the correct answer for this question will be equal to 6.33%. Am I clear to each and every one of you? Yes or no? Now all of you have given answer as 8.33%. The correct answer for this one is 6.33%. Give me a yes or a no if you have understood this one or not. Okay, now let's move on to Let's move on to next question. Pavitra, good afternoon. Pavitra, it's evening time where I live. So good evening to you. Okay, so answer was 6.33, and let's move on to our next question, question number 2. Now, question number 2 on your screen. In the figure below, now there are two parts of this question. As you can see, how many straight lines can be drawn by joining the dots? So you can see various dots at the bottom. Okay, how many lines can be drawn by joining the dots? Now, Gibson, Alexander, please quickly mention which part you could not understand. If you can go back and look at the explanation once again, probably you will understand. Otherwise, please mention specifically which part you could not understand. Okay, so how many straight lines can be drawn by joining the dots? You have to find out the total number of straight lines. A very simple concept, a very straightforward concept is or will be applied in this particular question. Let's see how many of you can quickly get me an answer. You don't have to be afraid if they will make a figure like this. I'm sure if you have covered permutation combination, then you must have covered this particular concept. So only part A is what you have to do. How many straight lines can be drawn by joining the dots? All right, Music Core says 63 will be the answer. Nice. Okay, Gibson, 300 was an assumption. Since the ratio was 1:2, so I have just assumed the number as 300. Okay, so it was just an assumption, nothing else. Yes, Aditya. Aditya has mentioned. Okay. All right, so let's have a look at this one. How many straight lines can be drawn? Now, what is the total number of dots that you can see? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 on each of the sides and 3 at the corners. So total number of dots is 18, right? Now, number of lines will be 18C2 if all these points are non-collinear. Okay, so 18C2 will be the number of lines if all these points are non-collinear. But there are some points which are collinear. So let's see how many lines cannot be formed. Okay, now I'll consider first side AB. On side AB, there are 7 dots. Okay, now these 7 dots are collinear with respect to each other. So among these points, among these dots, 7C2 lines which could be formed will not be able to form because these points are collinear. But one line can be formed, that is this one. Okay, similarly, take another side BC. On BC, again, there are a total of 7 dots, because of which 7C2 lines could not be formed, but one line can be formed among them. Similarly, the third side AC, minus 7C2 plus 1. So simplify this value and you will get the answer. Okay, so can you all simplify this and give me the final answer quickly? Now 18C2 will be 18 into 17 upon 2, 17 into 9, that is 153, minus 7C2 is 21. Now 21 3 times hai, so minus 63 plus 3. So 153 minus 63 is 90, 90 plus 3 is 93. So 93 should be the final answer for this question. All right, so this is how we simplify, this is how we solve these type of questions. I'll explain it again. 18C2 will be the total number of lines that can be formed if all these points are non-collinear. But on the 3 sides, group of 7 points are collinear. So on one side, 7C2 lines could not be formed. On the other side, 7C2 could not be formed. On the third side, 7C2 could not be formed. But one each line can be formed on each of these sides. So I'll add +1 +1 +1 three times, and that will be the final answer. All right. Now let's look at the second part of this question. How many triangles can be formed by joining the dots? So you will approach this particular question in the similar manner. So 18C3 can be the total number of triangles if all the points are non-collinear. But since these set of 7 points are collinear, 7C3 triangles could not be formed among them, right? But I cannot form any triangles, so there is no need to add anything. Similarly, for the next set of points, -7C3, and the third set is -7C3. So for this question, this will be the final answer. All right. Now you can simplify this result and you can find the final answer. We will not invest the time towards simplification. I'll just quickly tell you. Okay, so this will be the final answer. 18C3 -7C3 -7C3 -7C3. So the final answer will be 711. I'll not invest time in calculations. We can move towards the next question. Okay. So yes, 93 and 711 are the final answers. Let's move on to question number 3. Question number 3. If there are 7 periods in each working day of a school, then in how many ways can one arrange 5 subjects so that each subject is allowed at least 1 period? We have moved towards the next question. So there are 7 periods in each working day of a school. Then in how many ways can one arrange 5 subjects so that each subject is allowed at least 1 period? All right, Pradeep, Draken, Music Core. Let's see what will be the answer. A few more seconds. Now this one is easy, not that difficult. So let's do the analysis. Okay. Now 7 periods, 1, 2, 3, 4, 5, 6, 7, and let's say there are 5 subjects A, B, C, D, E. Okay. Now 5 subjects will take any of these 5 places. Now we have to arrange these 5 subjects so that each subject is allowed at least 1 period. Okay. So there can be 2 different possibilities. All right. Now the 2 remaining slots are occupied by 2 different lectures, 2 different subjects, okay, or 2 remaining slots are occupied by the same subject. Case number 1, when 2 remaining slots are occupied by different subjects. So that means I need to select which are these 2 subjects. This can be done in 5C2 ways. Okay, so now I have a case like A, B, C, D, E, and any of the 2 subjects are repeated twice. Let's say like this. So we have a total of 7 in which D is repeated twice and E is repeated twice. So multiplied by simple arrangement, 7 factorial divided by 2 factorial into 2 factorial. All right. So this is case number 1 when the remaining 2 slots were occupied by 2 different subjects. Next, second case, when the remaining 2 slots are occupied by the same subject. That means we just need to select any one of the subjects out of 5. So 5C1 is the way how I will select. Now I'll have a case like A, B, C, D, E, and one of the subjects will be repeated 3 times. So arrangement will be 7 factorial divided by 3 factorial. Okay. Now we have these 2 cases, case number 1 and case number 2. Just add these 2 cases and that will give you the final answer. Okay. You just need to add these 2 cases to get or to obtain the final answer. Now, do you want me to do the calculations? Do you want me to do the calculations, or can I leave it here and move on to the next question? Come on, just quickly tell me. Do you want me to do the calculations, or we can move on to the next question? Akhil has already done the calculation. Akhil, I take your answer. So yes, 16800. So 16800 will be the final answer for this one. Okay. So I'm leaving this calculation. Calculations यार अपने आप कर सकते हैं हम, ठीक है? Okay. So 16800 is the answer. Let's quickly move on to the next question, question number 4. Thank you, Pradeep, Shweta, Aditya. Next, good. So this is our next question, question number 4. Now this is a wonderful question, conceptual question. In how many ways can 7 different letters can be posted into 3 post boxes? Normally the answer will be 3 raised to the power 7, but there is a condition to this, such that no box remains empty. That means at least one letter will go in every letter box. Now this is a twist in the question. So definitely the answer will not be 3 raised to the power 7, because there is a condition attached to this. Obviously we are not here to do straightforward questions. We are looking at the questions that may appear in our CAT examination. No, Varun, derangements cannot be used here. Let's see how many of you can give me the answer for this one. Piyush, no, 15 is too less. All right, music core. Draken, calculate this answer. Now you are saying 3 raised to the power 7 minus 7 factorial. Now value of 3 raised to the power 7 will be less than 7 factorial. So your answer will come out to be in negative terms. No. All right. Okay. Let's see what we need to do. Okay. Now, if I'm writing the answer as 3 raised to the power 7, then what can be the different possibilities that would have happened? First letter box, second letter box, third letter box. So it may be possible that we have at least one letter in all these letter boxes, like 2, 3, and 2. 2 letters, 3 letters, and 2 letters. Okay, so none of the box is empty. Now there may be a case in which one of the boxes may be empty. That means 4 letter has gone to this letter box and 3 to this and 0 to this. So this type of cases are included in 3 raised to the power 7. We have to remove those. Okay, right? Now next is, it may be possible that I have all the letters in the same letter box. Okay, and 2 of the boxes are empty. So I'll also have to remove those cases. Clear? So these are the cases that I have to remove from 3 raised to the power 7. Okay, now let us talk about this. So 3 raised to the power 7, can anyone give me the value of this? I'll require it later. So first is when one box is empty. I'll calculate these cases and will subtract. Okay, when one of the boxes is empty, right? Now when one of the boxes is empty, that means 2 letters are distributed in only 2 letter boxes. Sorry, 7 letters are distributed in 2 letter boxes. The total number of ways is 2 raised to the power 7. But it will also include one way when this letter box is empty and another way when this letter box is empty. So I'll subtract 2 and this will give me the number of ways in which 7 letters will go in exactly 2 letter boxes. All right, fine. That means the third box will be empty. Now, third box will be empty. So it may be possible that second box may be empty or the first box may be empty. So this will be multiplied by 3. So there will be 3 parallel cases to this. All right. So 2 raised to the power 7 minus 2 multiplied by 3. All right. Now 2 raised to the power 7 is 128 minus 2 is 126 multiplied by 3. Now 126 multiplied by 3 will be 328. So this is the first case that we will subtract. The second case, when all the letters will go in a single letter box. So all letters will go in first, all will go in second, all will go in third. There will be 3 such cases. Okay. So we'll subtract both these things from 3 raised to the power 7. So 3 raised to the power 7 minus 378 minus 3. This should be the final answer. Okay. So 2187 minus 381. Let's calculate this. 6, 0, 21 minus 3, 18. So the correct answer for this question should be 1806. And yes, I have seen this answer from some students. So Akhil, Education Word, and Varun, 3 students have given the same answer. Lovely, lovely to see this thing. Okay, nice. So 1806 is the correct answer for this question. So I hope you all understand how have I calculated everything. Yes, Kaushal, absolutely 2187 minus 378 minus 3 will be the final answer. Okay, let's move on to question number 5 quickly. In how many ways can we get a sum of at most 20 by throwing 4 different dice or 4 unbiased different dice? So we need number of ways in which you can get a sum of at most 20. A very simple question. Very, very simple question. Now here you can use the formula of some number of natural number solutions. So 4 dice, A plus B plus C plus D, okay, equal to whatever, and you can use the formula sum of these 4 numbers is equal to whatever you want to write it, and you can use number of natural number solutions formula. But before that, you will have to have an understanding of one more concept related to the sum of the numbers appearing on any number of dice. Now, Kaushal, 1296 will be the total number of cases. This will be the sample space. So 1296 obviously cannot be the answer. And I'll make clear that this is also not the answer. Kaushal, 1296, 4 dice, yes, I understand, but that is the sample space. Okay, that is the total number of cases. But I need the number of ways in which we can get a sum of at most 20. Okay, so can you all tell me what is the minimum sum that can be obtained? All of you, what is the minimum sum that can be obtained? Quickly keep on writing some of the answers to the questions that I'm going to ask you now. What is the minimum sum that can be obtained? Now, minimum sum for 4 dices will be 1 plus 1 plus 1 plus 1, that is 4. And maximum sum that can be obtained is 6 plus 6 plus 6 plus 6, that is 24. Okay. Now, irrespective of the number of dice, all of you listen carefully, for some minutes. Irrespective of the number of dice that you are playing with, the number of cases for minimum sum, which in this case is 4, number of cases that is obtained, number of ways in which I can obtain this minimum sum, will always be equal to number of cases or number of ways in which the maximum sum can be obtained. All right. Similarly, for second minimum, number of cases will be equal to second maximum, second highest. Number of cases for next will be equal to number of cases for next lower value. And so on. This will keep on happening in every number of cases. Okay, so irrespective of the number of dice, this will always happen. Number of cases are equal. Am I clear up to this point? I hope I am. Okay, now for this question, let's do the framework. Now we need to get a sum of at most 20. मतलब ज़्यादा से ज़्यादा 20 आना चाहिए. That means 4, 5, 6, 7 and so on up till 20. These are the different values of the sums that we require. All right. So one way you can do this question is the sum of four numbers a plus b plus c plus d is equal to 4. Start from the minimum value. Calculate, find out the number of natural number solutions, then put it 5, 6, 7, 8, 9 up till 20. I believe the question will be very lengthy if you are going to do it using this way, right? So what I'll do is I'll calculate for the last four values. So up till 20 tak mujhe calculate karna hai. So I'll calculate it for 21, 22, 23 and 24. And whatever the number of ways will be, I will subtract it from the total number of ways. All right. I will subtract it from the total number of ways. Let's do that. Now I need it for 21. Number of ways for 21. This will be equal to when the sum is 7. Okay. So 7 pe apply kar sakte hain. Then for 22, it will be equal to 6. For 23, it will be equal to 5. And for 24, it will be equal to 4. Okay. So now I will calculate the number of cases when 4 is the sum, 5 is the sum, 6 is the sum, and 7 is the sum. This will replicate to the number of cases when the sum is 24, 23, 22, and 21. And I will subtract it from total number of cases. Okay, so let's start this one. So when the sum is 4, that means a plus b plus c plus d is equal to 4. The number of cases will be number of natural number solutions, right? Number of natural number solutions, s minus 1, c r minus 1. So 4 minus 1, c 4 minus 1. Okay, that is 3c3. There will be one case. When the sum is equal to 5, then the formula will be 4c3. That is equal to 4. Okay, let's continue. When the sum is equal to 6, it will be equal to 5c3. That is equal to 10. When the sum is 7, it will be equal to 6c3. That is 6 into 5 into 4. That is 20. Okay. So now what is the sum of these cases? 1 plus 4 plus 10 plus 20. That is 35. So 35 is the number of cases that I need to subtract from the total number of cases. What is the total number of cases? 6 into 6 into 6 into 6. That is 1296 is the total number of cases. From here, I'll subtract 35 and the final answer that I'll get will be 1261. So 1261 will be the final answer for this question. All right. Yes, Jaydev, absolutely. So option A is the correct answer. Okay. Now with this, let's move on to our next question. Question number 6. Now question number 6 is a lengthy question. So I would like to start it immediately. You must understand. Now this question is related to finding the rank of any letter when all the words that can be made using the alphabets are arranged in the form of are arranged in the form of a dictionary. So Question says that if the letters of the word listen are permutated in all possible ways and then they are arranged according to the words are arranged in a dictionary, okay, then how many letters, how many words will be lying between listen and silent? Okay, right? Understood? So this is a basic question related to finding the rank of a word. Now, I'll first of all write all these alphabets. We'll calculate the rank of listen, we'll calculate the rank of silent, and we'll see how many words will be lying between them if all these words are arranged in the form of a dictionary. Okay, let's do that quickly. So I'll be a little slow, fine, I'll not do it quickly. I know the method. I just want all of you to understand the method as well. So whatever alphabets are given, I'll arrange them in alphabetical order. E, I, L, N, S, T. Now, first of all, I'm looking at finding the rank of listen, Listen. Okay. Now, alphabetically, first of all the words that will start from E will appear. Now, E, if it is fixed, then the remaining words, remaining alphabets are 5. So, starting from E, a total of 5 factorial words will be formed. Then the next alphabet will be I. Again, 5 factorial words will be formed starting from I. Next alphabet will be L. Now I need L at the beginning, so I'll remove L. Okay, L is fixed now. Now the words which will start with L, among them the first set of words will start from LE. Again, I'll go alphabetically. Okay, so LE. Now do I require LE in this word? I don't. So I'll make all the words which are starting with LE. So it will be 4 factorial. Then next after E, I will come. Now Li. I require Li at the beginning. Okay, so I will also be fixed. Now beginning with Li, the first set of words will start from E, again alphabetically. Now do I require Lie? No, I don't require Lie in the word. So I'll not fix it. So Lie से कितने words बन सकते हैं? 3 factorial. Then after LIE, it will be LIN alphabetically. So again 3 factorial. After LIN, I will have LIS. Now I require LIS, so I'll fix S as well. Okay, I'll fix S as well. Pradeep, you have already calculated the answer. That is wonderful. I'll be a little slow. I'm explaining all the students. Okay, so let's see if this is the answer or not. So LIS, I need it. Okay, so I'll fix it. And LIS से start होने वाले सबसे पहले words क्या आएंगे? LISE. Now I don't want LISE, so 2 factorial words will start from here. Okay. Now after LISE, it will be LISN. Again, I don't require this. 2 factorial. After this LISN के बाद T आएगा. T is required. Fix कर देते हैं. उसके बाद first letter will be E and then N. So this is my required word. All right. Now, can anyone tell me what is the sum of these numbers? 120, 120, 24, 6, 6, 4, sorry, 2, 2 and 1. So 240, 270, 281. So it is 281 that I am getting. All right. So 281 is the rank of listen. Let's move forward and look at the rank of silent. SILENT. I'll write all these alphabets again. EILNST. Okay. Now, why I have taken this question? Because I want all of you to understand this. So I have taken 2 examples, 2 different examples. So again, E से start करते हैं. ILN. So before S, all these alphabets will come. Each of them will be 5 factorial. So there are 4. So 5 factorial into 4, that is 480. So I have reached up till 480. Now S will be the alphabet. Okay. Now S से start होने वाला सबसे पहले SE आएगा. SE is not required, so 4 factorial here. Okay, right. Next SI will come. So S is fixed, I will be fixed because SI is required. E, then 3 factorial, then SIE के बाद SIL, SIL is required. Then SIL को fix कर दिया. Next letter will be ENT. So ENT will be the next word. So it will be 1. So 24, 6 and 1. So 510, 511. So the rank here will be 511. Okay. So 281 was the rank of listen and 511 is the rank of silent. Now, what will be the number of words that will be lying between them? Now, if you write the answer as 511 minus 281, so that will be 230, but it will give you the number of words after listen up till silent. So listen के बाद जितने words होंगे including silent is 230, but I need the number of words between them. So एक और minus करना पड़ेगा and the correct answer should be 229. So Pradeep, earlier you have given the answer as 230. I understand that you have made the correction. Good that you have made the correction. Okay, so the final answer for this question will be 229. Okay, because I need the number of words between them. Understood? So the correct answer is option B, that is 229. Right? Let's move on to question number 7. Question number 7, an easy one to all of you. Quickly give me an answer for this one. 6 cross or X have to be placed in the squares of the figure such that each row contains at least one X. In how many ways this can be done? Each box can take at most one X. So you cannot put 2 X's in a box. Yes, Kaushal, this is the only technique. You're asking about the last question. Yes, that is the only technique that we used. Now, since we calculated the rank of 2 different words, that is why it has gone lengthy. Otherwise, generally you will see finding the rank of only one word. All right, any answer for this current question? All right, education word, good. Music course says 80, nice. So 80 and 81 are the two options, are the two answers among the options that I have got. Okay. Now at least one X in each of the rows is what I need to take care. Now I can make different cases. So if in the first row I'll put 1, in the second row I'll put 2, and in the third row I'll put 3. So 6 to be divided in 3 parts, 1 plus 2 plus 3 is one way I can do it. Okay. So if I'll put 1 cross in the first row, it can be done in 3C1 ways. Okay. In the second row, out of the 3 boxes, I need 2. So 3C2 ways. And for the third, it is 3C3 ways. Okay. So 3C1 into 3C2 into 3C3. All right. And then this will be multiplied by, now I have 1 in the first, 2 in the second, 3 in the third. This can also shuffle, as in 2 in the first, 1 in the second, 3 in the third. So 3 factorial से multiply हो जाएगा. All right. So this is one of the cases, right? Now 6 can also be divided among three numbers as 2 plus 2 plus 2. So let's make the second case when I'll be putting two crosses in each of the rows. So it will be 3C2, 3C2 and 3C2. Since all the rows have equal numbers, so there will not be any kind of arrangement. So there will be another case that will be added, 3C2 multiplied by 3C2 multiplied by 3C2. Okay, clear? So just add these two numbers and get the final answer. 3 into 3 into 1 multiplied by 6 plus 3 into 3 into 3. So 54 plus 27, and the correct answer is 70, 80, 81. So 81 should be the correct answer, which is option B. All right, clear? Kaushal, 4 cross we cannot apply in a row because each of these rows has only 3 boxes. So 1 plus 1 plus 4 cannot be done. Okay, so that is why I have not considered it. All right. Kaushal, I've just explained that 1 plus 1 plus 4 cannot be done because there are only 3 boxes in a particular row. Okay. All right. So the correct answer here is 81. Let's move on to question number 8. So question number 8, one ticket is selected from random 91 tickets numbered 00 up till 90. Be careful with this question. This is a question of conditional probability. Yes, Kunal, 9C3 minus 3. Yes, we can do that. So we have to select, good. We have to select 6 boxes. So out of 9, so I'll select 3, which I have to leave empty, and making sure that there should be 1. Yes, so minus 3, 1, 1 and 1. Yes, so Kunal, yes, you can do that. 9C3 minus 3, but it will be slightly difficult to explain, understand. Okay? So yes, that method can be used. Kunal, question number 8. All right. Careful, huh? This represents conditional probability. Probability that x is equal to 8 given that y is equal to 0. Okay, wonderful. So let's have a look at it. Now we are selecting one ticket out of these numbered tickets. Numbers are 00, 01, 03 up till 90. X is the sum and Y is the product. Okay. Now we have to find that X is equal to 8 when Y is equal to 0. So first of all, I'll write all those cases when Y is equal to 0. That means the product of the digits will be equal to 0. Now product of the digits will be equal to 0 if any one of the digits, if at least one of the digits used in that number will be 0. So y equal to 0 can be obtained as 00, 01 up till 10, and then 20, 30, 40, 50, and so on up till 90. So what will be the number of cases? Yes, what will be the number of cases? What will be the number of cases? So these are 11 cases, okay, and these are 8 cases. So a total of 19 cases will be there when y is equal to 0. A total of 19 cases will be there when y is equal to 0. Now, out of these 19 cases which I have written, okay, so let's write them again. So I want y to be equal to 0. Okay, so the numbers can be 0, 0, 0, 1, 0, 2 up till 0, 9, and then 10, 20, 30, 40 up till 90. So these are 10 numbers and these are 9 numbers. So a total of 19 numbers are there when the product will be equal to 0. Okay, out of these written numbers, in which case x will be equal to 8. That means the sum of the digits will be equal to 8. So sum of the digits will be equal to 8 in 0, 8 and in 8, 0. So there are only 2 such cases. Okay, so simple probability, the answer will be 2 upon 19. Okay, so out of 19 cases, 2 are favorable. 2 upon 19 will be the final answer. Clear? Let's quickly move on and look at the next question. The last question, an easy one for all of you. Now, 3 integers are chosen at random from the first 15 natural numbers. What is the probability that their product is a multiple of 3? Quickly give me an answer for this. An easy question for all of you. So we are selecting 3 integers from the first 15 natural numbers. We need to find the probability that the product is a multiple of 3. Subrat, what will be the answer among the options? Okay, Akhil says option A. Now we'll use a very simple method of finding this. So what I'll do is I'll calculate the probability that the product is not a multiple of 3 and we'll subtract this probability from 1. So 1 minus the probability that the product is not multiple of 3. Alright. Now the product is not a multiple of 3. How this will be possible? This will be possible only when none of the 3 numbers selected will be a multiple of 3. Okay, so the 3 numbers that we are selecting, none is multiple of 3. Alright. Now out of 15 numbers, how many are multiples of 3? There are 5 numbers which are multiples of 3 and the remaining 10 are not multiples of 3. So that means these 3 numbers are selected from the set of these 10 numbers which are not the multiples of 3. So number of ways in which this can be done will be 10C3, alright, divided by total number of cases 15C3, and I'll subtract it from 1 and we'll get the answer. Alright, so 1 minus 10 into 9 into 8 upon 15 into 14 into 13. Let's do the calculations. 2, 3, 3 and 7. So 1 minus 24 upon 91. And 91 minus 24 is 67 divided by 91. So 67 divided by 91. Yes, absolutely correct. Given by Akhil, Education Word, Kaushal and Pradeep. So the correct answer will be 67 upon 91. All right. Okay. So that was the last question of today's lecture of Last Lab to CAT 2022 for modern mathematics. I hope you like this lecture. If you like this lecture, please quickly press the like button. I forgot to tell you at the in between this lecture, but if you haven't liked it yet, please quickly hit the like button. Come on, do that. So looking at the schedule of the upcoming sessions, so these are the next 5 sessions that you will be seeing. So on 11th of November, Gautam Bawa sir will come with CAT 2022 QA Decoded Smart Techniques to Ace Quant. Must attend sessions, all these are. 12th of November, Srinivas sir will come up with Revised Arithmetic with Important Concepts. Then Saral sir will bring 2 sessions for Algebra and Arithmetic. And then Srinivas sir will come with grid-based problems on these 5 days. All right. Now, 27th November is the date for CAT. Most of the students who are taking examination in second and third slot will be waiting for the first-hand analysis of this paper. So we'll be present in front of you live immediately after each of these slots with the detailed analysis of every slot. So do join us on 27th of November live on the YouTube channel of BYJU'S Exam Prep for an in-depth analysis of CAT examination. Any student who wants to join CAT 2023 comprehensive program, this is the complete details about that program. You can join this and start your preparation with BYJU'S Exam Prep. You can follow us on these social media platforms. I hope you enjoyed this session. Thank you very much for being there, for being a part of this session. Have a nice day to all of you. Bye-bye. Yes, Kaushal, NMAT will ask these type of questions. Yes, PNC and probability is a part of Narsi Munji. Aditya, yes. Now, definitely the level of difficulty will not be as high as that we have seen, but you may expect questions from PNC in the examination of NMAT. All right. So that's all from my side, my dear friends. Have a good night. We'll see you again. Take care. Bye-bye.